Okay, which one did you say? Oh, that's right. There was more than one question about that, huh? Yeah, should I turn that off? Should I make it not do that anymore? Should I make it not do that anymore? Is that going to bother you? Maggie can hear me better now. Okay, the, so um, sometimes, yeah, if I have the speakers and the top of the ceiling going, then it'd be super awesome. The speakers at the top of the ceiling, they don't work anymore. I don't know how to get those to work. So, what's that? No, it was just something in the wiring. Okay, so for F it says find the equations of the asymptotes. So we have two vertical asymptotes and two horizontal asymptotes, right? Okay, which one do you want to do first? They're all the same. So let's do the horizontal ones first. So if I do the limit as x approaches negative infinity, what y value is this graph approaching as it goes to the left? 2. Okay. Yeah, that's it. And then if we want to do the horizontal asymptote going the other way, what y value is it? Okay. So those are the two horizontal asymptotes. Okay. The vertical asymptotes, instead of doing the limit as x approaches infinity and that equals a number, you do the limit as x approaches a number and that equals infinity. Okay? So for this one right here, that's what? -1. So I'm going to do the limit as x approaches -1 from which side? From the left. No, from the negative side, from the left. So that equals infinity. So that means this is a vertical asymptote. These two, by the way, were horizontal asymptotes. Okay? And so what would be the... oh, I didn't see that, Gage. We could have done from the positive side also. Yeah, my bad. Yeah, then this last one would be the limit as x approaches 2. In this case, also equals positive infinity, so those are the vertical asymptotes. Well, right. And so I guess I should include both of those right here. So we will probably have to also say that the limit as x approaches -1 from the positive side. I was thinking about that yesterday, actually, when I was teaching this. I wasn't sure if we always need to have a left hand and a right hand limit in order to make that work. Yeah, go ahead. Okay, so now the same thing on number 4. It's normal, yeah. Okay, so hold on. Before we get into Katie's thing, this is going to answer the question that I just had. This one right here, the limit as x approaches -2 from the negative side is negative infinity, right? But the limit as x approaches to as -2 from the negative side, did I just say that wrong? Sorry. The limit as x approaches -2 from the positive side is negative infinity. But the limit as x approaches -2 from the negative side is just 1. So is that an asymptote or not? No? You need to have both a left and a right hand? But it seems like it could be an asymptote going down. So I'm not really 100% sure, so I'm glad they threw this example at us so that I can look it up and find out. Do you need to have both a left and a right hand, or is one enough? So this is section, yeah, right. If we're doing geometry, it would be like array. Array is that fish that that swims in the sea. That was really hard for me, just so you know, because I could hear the echo also, but I was still like talking, and so it was hard. Yeah, so it's hard for me to concentrate on what I was saying and not thinking about. Okay, so in this case, Shaden is right and Katie is wrong. You only need either a left hand or right hand limit for there to be a vertical asymptote. Okay, Maddie, have your phone, please. Okay, so was that what was your question though? What was okay, so you got it? You're good? Okay, and then Shaden, you said did you just ask why it's so hot in here? Oh. Haha, okay, so Shaden, number 9. What is the highest power of x on the bottom? 1. So I'm going to multiply everything by 1 over x. So if I multiply 1 by 1 over x, what do I get? Yeah. 1 over x. And then if I multiply 2x by 1 over x, what do I get? 2, right? Because the x's cancel. And then if I multiply 3 by 1 over x, what do I get? 3 over x, okay? Then what we learned yesterday is anytime you have a number over x to any power, if you're taking the limit as x approaches infinity or negative infinity, those just go to 0. So this would be 0 over 2 plus 0, which is 0. Because, man, were you here yesterday? Because as the number on the bottom gets larger and larger and larger, 1 over that gets smaller and smaller and smaller. Okay, can I have you guys' assignments, please? Seems like it, yeah. Well, I remember that we did limits at the beginning of the year. I feel like, do you want to finish that up and give it to me, or do you want to start out 2019 with a big fat? Yeah, I'm recording for Hero and Mason. I should be recording every day. Our day. What's that? But isn't my goal as a human being to lead the best life that I can? Yeah. And so you're putting the opportunities out there for us to learn. You're not on video. Therefore, I don't need permission. Yep. And then yes, I'll record during business week. Yep. So what I'll do, Elena, is I post them on YouTube, and then I just send you the link to the video. And then you can watch it at your, yeah, every time a student is gone from my class, I should be recording, no matter what class it is, right? And then email that student the video of our stuff. And like Gage said, if they come back and they know it already, or if it's the other way and it's a kid that doesn't care and they just never watch it, that's on them. But I gotta, right, but I did what I could do. Yeah, okay. All right, so let's keep working on these a little bit. This says compute the limit as x approaches infinity of square root of x squared plus 1 minus x. Well, I'm about to learn you. One really distinct difference between this and the other ones that we've done is what? There's no denominator. So what we're going to do is we're going to change this into a problem that has a denominator. This is one of the few times when having a fraction actually makes your lives better, okay? And so what I'm going to do is I'm going to multiply the top and the bottom by the complex conjugate. So the way that you do that, Payson, is you just take and change. You really could change either sign. You could change this to a plus Or you could leave that as a minus and change the square root to a minus, as long as you change one of them. Because then when you multiply these out, what happens is when I go first times first, the square roots cancel, so that's handy, right? That gives me x squared plus 1. And then I'm not even going to do the inside and the outside, because they're going to cancel because one's negative and one's positive. So if I multiply these together, I get x times that. If I multiply these together, I get negative x times that, cancel. And then negative x times positive x is negative x squared. And then this is over x squared plus 1 plus x. Right, so then this comes out to be good because the x squareds cancel. So this is 1 over that equation. And what is that going to work out to be? What's the theorem that we've been using? It is 0, because 1 over increasingly large number ends up being 0. Okay? Okay, hang on just a second. Yeah, and we're supposed to do the multiply by the 1 over x thing to figure that out, but it feels to me like we can just know that at this point. What's your question? To make a fraction that way? That is a good question, and the answer to that lies in a mistake that I made yesterday, which is, it's a good time for me to fess up as a teacher and tell you that I made the mistake. I've been saying that we multiply by 1 over the largest power of x. It's 1 over the largest power of x in the denominator. Okay? So if I made this as over 1, what would be the largest power of x in the denominator? No, 0. And so I'd have to multiply by 1 over x to the 0, which is just 1, which wouldn't get us anything at all. Okay? So that's why. So we need to actually have an x on the bottom. So that's a good question. Thank you for asking it. It's 1 over all this stuff, and so technically I'm skipping a little step here. What we're supposed to do is we're supposed to say the largest power of x in the denominator here is 1. So I'm going to take and multiply everybody by 1 over x. So this would become 1 over x. 1 over x underneath the square root is 1 over x squared. So if I multiply this by 1 over x squared, then that cancels and makes this 1. Then this would be plus 1 over x squared, and this would be plus 1 over x, okay? And then now we're supposed to be able to say 0, 0, 0, so 0 over the square root of 1, which is 0, okay? But we kind of see that. Oh, what'd you say? You multiply by 1 over x squared. Yep. Okay. Okay, so then we'll just do some weird things here at the end. Oh, and then we do have to get into something. Oh, we're going to sketch a graph, so that'll be fun. All right, so the next example says evaluate the limit as x approaches infinity of the sine of 1 over x. So this is a little bit of a weird cheat, but we're going to say let's let t equal 1 over x. Okay? It's just a variable that I made up. All right? So then what happens to this as x approaches infinity? T goes to 0. So that means I can rewrite this as the limit as t approaches 0 of t. Oh, sorry. Thank you. I knew that was too simple. The limit of t approaches 0 of the sine of t. Okay? And then what's the limit as t approaches 0 of the sine of t? What do you get when you just plug 0 in? What's the sine of 0? 0. So our answer here is 0. Okay? This would be a problem that like maybe there would be one like this on the AP calculus test, and that's the only time you would ever need to know this little trick. So if you're a little bit out of your element looking at this, then that's okay. Okay. All right. Then sometimes for all you Mean Girls fans out there, the limit does not exist. So for example, if you have the limit as x approaches infinity of sine of x, if you think about the sine graph, it's of course oscillating, going up and down, up and down, and up and down. So it's not approaching a particular value. There is no horizontal asymptote, so this one does not exist. Okay. Someday, I don't remember what the other person said in that scene, or even if they did have an answer. She did answer it. Oh, and then she had time. She's like, if you, right, then you guys are math state champs. I remember sitting behind the cute boy with the hair, and then she can see Tina Fey like past his hair doing that. From a movie, Mean Girls movie reference. All right, let's see. Then we can do some limits that are approaching infinity as x goes to infinity. For example, the limit as x approaches infinity of x cubed would be what? Okay. That would be kind of funny. What is the limit as x approaches infinity of x cubed? It is infinity, yeah. Because if you put in bigger and bigger numbers and you cube them and cube them and cube them, then it's going to get bigger and bigger and bigger, okay? Yes, good. And so since this is a odd exponent, if you put in larger and larger negative numbers, when you cube those, they stay negative, so this answer becomes negative infinity, yeah, okay? All right. Then here is a common mistake that we don't want you to make. When it says find the limit as x approaches infinity of x squared minus x, you say to yourself, oh, x squared is going to infinity and x is going to infinity, and infinity minus infinity is 0, so the answer is just 0. Okay? That is incorrect. You can never do math with infinity. Okay? Infinity minus infinity could be infinity. It could be 0. It could be negative infinity. It could be all kinds of weird things. It depends on which infinity is bigger. Okay? So the way that you solve this problem is you actually factor out an x first, like that. Okay? And then now that you have multiplication, if you are putting in a larger and larger number times a larger and larger number, what's it going to equal? And is it going to be like a particular positive number, or is it going to be like 0 or 2 pi, or it's going to be infinity squared, which is just infinity. Okay? So it's weird, but this x squared term is going to infinity faster than this x term, so that when you subtract those, the answer is actually infinity. Yeah, and the guy that figured that out, that classified infinities and did some math with infinities, he ended up going crazy. And I don't know if he was like on that. His name was, you would pronounce it George, but it was a guy named Cantor, and there's things called Cantor sets where you classify different infinities. And so, for example, an easy way to think about this is if I asked you how many positive whole numbers there are, what would you say? Infinity, right? But if I asked you how many positive rational numbers there are, which are fractions, how many would you say? Infinity. But you can intuitively understand that if I look at a number line and I go 1, 2, 3, 4, since in between all of these there's like, what's bigger than 1? There's 5/4, and there's, you know what I'm saying? There's 6/4. There's more numbers Yeah, there's infinite ones in between there. So you have an intuitive sense that the rational numbers is a larger infinity than the whole numbers, right? But then when you think about it and the back of your head starts to hurt, it's infinity versus infinity. They should both still be the same. So there is some math that you can do there, and this guy figured it out. I think he's on here somewhere. And then he ended up going, I mean, you spend too much time thinking about infinity and exactly, yeah. No, I don't know his whole. I don't know his whole story. I shouldn't be. I shouldn't be spreading rumors about him. Okay. Last one of these limits. How would you? This would be a good one for you, Shaden, because you were asking about this gauge. Same thing. And this reveals the mistake that I made yesterday when I told you to multiply by 1 over the largest power of x. It's 1 over the largest power of x in the denominator. So I'm going to multiply this top and bottom by, 1 over x, not 1 over x squared. When I do that, x squared times 1 over x is x. So this will be the limit as x approaches infinity of x plus 1 good over, nope, 3 over x minus 1. Okay? And then so since we're doing limits as x approaches infinity, this is going to go to 0. What is the top going to go to? More specifically, infinity, because bigger and bigger numbers plus 1 are just going to get bigger and bigger and bigger. But I'm dividing it this time by -1, and so that means this limit is actually negative infinity. Okay? What's that? Well, that's a good question, but since we're saying x is approaching positive infinity, not negative infinity, in this case it can't be. We're only... sure, let's look at what would the limit of this be if x approaches negative infinity. So we would do the same thing, right? I don't know. So yeah, then this would be his limit as x approaches negative infinity. This would still be x plus 1 over 3 over x minus 1. But yeah, you're right. Now since I'm approaching negative infinity, the top numbers would be getting smaller and smaller. So this would be negative infinity over -1, and that would flip it around and make it infinity. Okay? So let's look at the graph just for funnies, since you're asking good questions about it. What was it? X squared plus x divided by 3 minus. Whoa. Okay. Okay, so once again I'm a liar because both sides it's approaching positive infinity. What did we get for the first one? Positive infinity or negative infinity? Okay, no, the answer in the book has negative infinity. Maybe I need to zoom out a little bit. Ah, ha, ha, there we go. Okay, it was hiding down here. Okay, so this is approaching negative infinity like we figured, and this is approaching positive infinity. So, good lesson to be learned there. We're talking about limits as x approaches infinity, right? So what am I doing in between -10 and 10? That's not even close to infinity. So we gotta get out into the real world there. Okay? Homeworko. I can't do that. It doesn't matter. I can't do that. How far did we go yesterday? To 18? Okay.